Another way that we're going to solve systems of equations is by elimination. Okay? Elimination involves getting rid of one of the variables in a system of equations so that you can find the value of that variable. The variable is eliminated by adding the equations together. Okay, that sounds complicated, but it's really not that bad. So here's an example. So I've got 2x minus 3y equals 10 and 4x plus 3y equals 2. So what you're going to do is literally add the equations together. So I'm going to add my x's and get 2x plus 4x equals 6x. Then I'm going to add negative 3y and positive 3y. Well, minus 3 plus 3 equals 0. So I've eliminated that variable. That's where the name elimination comes from. And then 10 plus 2 is 12. So we're going to add those equations together and get 6x equals 12. I'm going to solve for x by dividing both sides by 6, and I get that x equals 2. Once I have an x value, I can now go back and find a y value. So I pick one of the two equations, I just picked the first one, and I plugged in 2 for the x value. So 2 times 2 minus 3y equals 10. So 4 minus 3y equals 10. Subtract 4 from both sides, and I get negative 3y equals 6. So I find that y equals negative 2. So I have x equals positive 2 and y equals negative 2. So I'm going to write the answer as a point. So negative 2, 2, that was the x and that was the y. And I'm going to check by plugging in both values into an equation. So I took the second equation, which was, if you take a look, which was 4x plus 3y equals 2. And I plug in positive 2 for x and negative 2 for y, pulling those numbers directly from my point. And I get 4 times 2 is 8, 3 times negative 2 is negative 6, 8 minus 6 is in fact 2, so it does work out. So another example. Sometimes it's not the y's that get eliminated, it may be the x's. If you take a look at this example here, you can see where this was positive 1 on top and negative 1 on bottom. When you add these together, your x's will totally disappear. 4y, and then you got to take the sign with it, minus 2y equals positive 2y. And then 12 minus 4 equals 8. So I solve for y. 2y equals 8. Divide both sides by 2, and y equals 4. Substitute in the 4 that you got for the y into one of the equations and solve for x. So x plus 4 times 4 equals 12. X plus 16 equals 12. Subtract 16 from both sides, and I get that x equals negative 4. So I have an x value and a y value. Well, that's all I need for a point, is an x and a y. So negative 4, 4 is my solution. It's the point where the two lines would cross if I graph them both. So I'm going to check my answer by plugging into the second equation. I'm going to plug in my negative 4 and my 4. So negative 4 minus 2 times positive 4 equals negative 4. So the negatives here cancel out, becoming positive 4. Negative 2 times 4 is negative 8. Once I combine those terms, I get negative 4 equals negative 4, which again is another true statement. It must be correct. So another example, just to show you how they can move a little quicker, you don't have to write out every step, is I've got 6x minus 2y equals 4, and 6 plus 2y equals 3. So I already see my y's are probably going to be the guy that's going to cancel out. When I add them together, I get 7x equals 7, because 6x plus x is 7x, and 4 plus 3 is 7. So I'm going to divide both sides by 7, and x equals 1. I'm going to use that value and plug it into this second equation here. So I get 1 plus 2y equals 3. 2y equals 2 when I subtract 1 from both sides. Y equals positive 1. So I get a value of x of positive 1 and a value of y positive 1. So the point where they cross is the point 1, 1. Step 5, check yourself. I'm going to plug in 1 and 1 to my very first equation. So I get 6 times 1 minus 2 times 1 equals 4. 6 minus 2 equals 4. 4 does in fact equal 4. That is the process of elimination.